Okay, hello everyone. We will like to introduce you to our web app, GuideSense. It's a real-time navigation app developed for visually impaired. My name is Abzia and I'm here with my teammates. Together, we are committed to making the navigation safer and more accessible for blind and visually impaired individuals. You can go to next slide. So this is our team agenda. Like whatever is included in the presentation, we have added the team member and responsibility slide, then improvements made by our professor, project overview, technologies we are using, tools we are using, personas, MVP, the diagrams, all which we are implemented, API code explanation, and also the demo, and the sprint matrix and test cases, also product backlogs. Next. So I'm the project manager and the developer.
Hi everyone, my name is Kain Chen. I'm the database administrator.
Hi guys, I'm Ritesh Singh and I'm a DevOps engineer.
Hello there. I'm Dinesh and I'm a developer.
Hello guys, I'm Rishabh and I'm a backend developer.
Hi everyone, I'm Vaibhav. I'm the developer lead and the front-end developer.
Hi, my name is Min Chang. I'm a quality analyst.
Hi, my name is Rishikesh and I'm front-end developer.
So this is the improvements slide based on professor feedback, what he asked to improve in the presentation we have implemented in the PPT. Next. So our problem statement is navigating to everyday environment presents significant challenges for blind and visually impaired individuals, like moving vehicles and lack of real-time guidance. Traditional mobility aids like cane and guide dogs, while helpful, often fall short for providing comprehensive and real-time information about obstacles and directions and surrounding. This means that blind and visually impaired individuals are frequently navigating without the full picture, leading to increased risk of accidents and restricting their independence. So this app is basically developed for safer navigation for them. So it gives like feedback of the real-time object detection uh, to navigate in day-to-day life safely. Next. This is the project description. Also, we have added the benefited outcomes, which uh, gives us increased independence, enhanced safety, improved mobility, greater confidence, accessibility, and inclusivity. And we have a GitHub link which shows all the details of our project. Next. This is a team working agreement. We created a set of rules to guide how we collaborate and stay accountable. We agreed to use WhatsApp for daily communication. We have Jira for tracking the task and progress. Everyone committed to attending all meetings on time, actively participating in discussions, and updating their tasks regularly. Uh, Also, when someone faced a blocker, we were helping each other. We also agreed to provide like feedback and conduct regular check-ins to reflect and improve. Overall, these agreements help create a positive and focused team environment, which contributed significantly to our sprint progress. Next. Next.
Here's the persona one of our user, which is the independent blind user, Aisha, and she's a software developer, and he want to use our web app to navigation while walking, especially in an unfamiliar area, and identify object could be a barrier for seamless task. Next, please. Our persona 2 is the concerned family member, and Robert is the son of the visual impact senior, and Robert want to use the app to check his mom's location and also receive alert if she disconnects from the usual routing or remote from the remote assistant her with the text line medication reminder and communication with her easier to the accessibility interface. Our persona 3 is the partial sight teenager, David. David has low vision due to the genetic condition, and David wants to use the app to magnify text and image, identify color, navigate public transportation, and access audio description of video and other media.
This side represents the minimum viable product of our system. At its core, it establishes a real-time video communication channel between the client and the server using WebRTC. The client, typically a web browser, sends a WebRTC offer, which the server responds to by setting up the connection and completing the handshake. Once the stream begins, once the video stream begins, each frame is sent to the server where it is processed using the YOLO object detection model. The system adds visual cues like bounding boxes around detected objects, sends the processed frames back to the client instantly. This flow forms the backbone of our MVP, ensuring the real-time object detection and feedback with minimal infrastructure. The core technology used in our product and so we are using Node.js serves as the runtime environment for the backend, while React powers the front end, enabling a responsive and accessible user interface. Python is used for real-time object detection, integrating the YOLO model through Fast API. For user authentication, we are using Clerk. It provides a secure and seamless sign-up and login experience. All user data is stored in MongoDB, our NoSQL database, and the application is deployed on AWS, ensuring scalability and reliability. On the management side, we use Jira to track project tasks and sprint, and we are using GitHub for version control, OneDrive for file sharing and documentation, and we're using idea boards to conduct a sprint retrospective and gather team feedback activity. So the model which we are using is called YOLO, you only look once. So it is a real-time object detection model known for its speed and accuracy. So unlike traditional methods that scan an image multiple times, YOLO processes the entire image in a single forward pass of a neural network, and it enables fast and efficient detections. It divides the image into a grid and predicts the bounding boxes and class labels and confidence scores for each cell. And it is trained on the COCO dataset with 80 object categories. So YOLO can accurately detect a wide range of objects. It uses non-maximum suppression to filter out overlapping boxes and retain the most relevant predictions. So thanks to its balance of speed and precision, YOLO is widely used in areas like autonomous vehicles, smart surveillance, medical diagnostics, and assistive tools for the visually impaired.
This is the architecture diagram, which shows the flow from the actor to the various components of the code. You'll see that the actor has the camera on in order to share the location, update preferences, see real-time object detection, log in, register, and capture speech results. And the user interfaces with the front end of a React and JavaScript, from which it sends to the backend the results from text-to-speech, log in through the Clerk UI, save common routes to the database, and request location through Google Maps API. And there are no changes to this diagram. Next slide, please. The context diagram shows from the start using the GuideSense web app, which follows through to family members and the YOLO object detection module, which follows through to the voice assist module, and which integrates voice feedback and visually impaired users to the end. From the start, it also goes to the end, and from the GuideSense web app to the family members, the location tracking feature and accessing location data also leads to the end. There are no changes to this context diagram. Next slide, please. The ER diagram shows that users can be managed. A number of users can be managed by one guardian or caretaker, and one user is assigned to one account, and a user has an ID, name, address, zip, and phone. The guardian and caretaker also has these attributes, and the account has an ID and password, which sets account preferences. There are no improvements to this slide. Next slide, please. The sequence diagram shows from the user to the caretaker and the guardian to the front end, which is used to add users, add routes, configure settings, and return routes. To the clerk, it checks if the user is authenticated. To the FAST API, it establishes a WebRTC connection. And to the AWS servers and the AI models, temp storage, backend, and database, and Google Maps API, it sends metadata, which is returned back to the user. The AI model stores root metadata into temp storage, and the temp storage also stores important and critical root data into the database. And the AI model returns the YOLO route back to the user. There are no changes. And the state diagram here also has no changes, which shows two states of idle and active. Idle being that it is off and not logged on, and active being that it is running, actively recording, and actively returning recording on route. And when the app is not active, it is in an idle state. There are no changes. The class diagram shows the user preferences, route, AI model, and database, each with its elements. There are no changes to this diagram. Next slide, please.
So this is a Sprint 2 recap. So what we did in Sprint 2, it's improved our detection model, implemented text to speech, completed technical paper, and integrated front end and back end. Next slide, please. So this is a product backlog, which is improved by the feedback from professor. As you can see, there are 3 user stories. User story 2 is as a visually impaired user. I want a single easy to find button that allows me to capture video using my device camera so that I can receive audio description. The acceptance criteria for this is application must provide an accessible interface that allows visually impaired user to easily capture videos. The story points is 8. Next. Next. Next slide. Yeah, thank you. Oh, I think so. So this is the technical story. Technical story 8. As a developer, I need to create diagrams like ER diagram, sequence diagram, class diagram, like Min just told. So for the entire product, which includes all core components, the acceptance criteria is the architecture diagram should clearly represent all major components as per feedback. Next. The technical story 10, here you can see as a developer, I want to review and update the diagrams. The diagram should be updated, should be reviewed with the team. So we have done that. And more test cases would be like the stories and test cases will be explained by the team in the sprint summary. Next.
Well, this is a sprint summary. So, in this point of view, we're gonna start from the sprint 1 user stories. Like, as a developer, I need to write a test cases for the sprint 0 to ensure that is a implemented features are working as expected, and I meet that the acceptance criteria too. For this acceptance criteria, all these user stories and technical requirements from the sprint 1, we should have a corresponding test cases that which covers the positive, negative, and the edge cases scenarios of it. And we done that too, and we completed that. And can you go for the next slide, please? So as you can see, the almost we have done all the sprint user stories. We have completed as you can see, the like these test case stories. So can you just move the slide, please? Well, so as the professor said, from the feedback, we improve the user stories too. So as the project manager, I want to ensure the seamless coordination between like technical components and stakeholders so that we can the systems meets both users and meet technical specifications also. Well, we completed that as the exception criteria of that like facilitate the regular communication between the stakeholders and the development team, track their progress, etc., etc. And we have there all key technical components and requirements also. So can you move on to the next slide?
Here's the spring one burn down chart. During the spring one, our spring planning created in the middle of the spring. We have been commit 45 story point, and but we haven't preparing for the spring one story at spring zero. Even we start the spring planning late, we still able to commit all 45 story point during spring one. Next, please.
Yeah, so after taking the feedback from Sprint 1, we made user stories for Sprint 2. Some of the important user story for Sprint 2 were the user needs the object detection. We used YOLO and YOLO2 for sending the JSON object. The story point for this use case was around 5. The second use case in this sprint was capturing the surrounding. We wanted the interface to be captured in our front end, and the story point for this user case was 8. Next slide. And the next user story for this sprint was text to speech and integrating the navigation. Um, the story point for this user case was 8. Next slide. And and we wrote technical paper also in this sprint, which had a story point of 5. In this sprint, the total committed story was 29. Next slide.
Here's the spring to burn down chart. At the beginning of the spring, we have commit 39 story point, and then we have complete 5 story point, and then we enter the spring break. Everyone was paused during the spring, and then we start to slow burning down the point in to meet the ideal line. And then at the end of the spring, we have completed the 8 story point. Next slide, please.
Hi, I'm gonna talk about the Sprint 3 backlogs. So it's user story, acceptance criteria, and the how many story points and the status. So the first one is just like as a developer, I need to create one AWS account for the project, and the project is gonna be deployed on the AWS server. So the acceptance criteria is the AWS account should be created and all the access credentials securely stored and the share in the authorized team members. It has story point of 2 and it's completed. And as a developer, I need to use their the compute services that's called EC2 instance to deploy their application on the server. The acceptance criteria, I would say the model it should properly run on that specific EC2 instance. It has a story point of 8 and it's completed. As a developer, I need to create a comprehensive deployment and an installation manual for the project so that other team member and future developer can easily access and for the setup for their environment. The manual should be include the clear step-by-step instruction for the environment setup, dependencies, installations, code deployment, and running the application, and should be accessible to the entire team. That has a story point 8 and the status is complete. Next slide, please. Next slide. As a developer, I need to write the test cases for the Sprint 3 to ensure that the implemented features are working as expected and meet an acceptance criteria. As a developer, I need to draft a technical paper that documents the design and architecture implementation details. challenges faced, and the result of the project so that we can clearly present our work for the academic or the professional review. The technical paper should include the section on the problem statement and methodology, system architects, technology stack, implementation details, challenges, result, and the future work, and it should be well structured and ready for the submission. It has a story point of 5 and it's completed. As a visual impaired user, I want to able to connect to the other user and grant them access to control my app temporarily so that they can assist me in navigating or using the certain features remotely when I need help. The system should allow a user to securely share access with a trusted user, enabling them to view and interact with the key controls in the real time with the ability to revoke access at any time. It has 3.5 and the state is incomplete. Next, please. Next slide.
Here's the breakdown chart for Spring 3. During Spring 3, we have commit 49 story point and complete 41 story point. And then during Spring 3, we have slowly burned down the story point, and then at the middle like in the gap of during the spring, we have hit the ideal line. But because Spring 3 is the final spring of this project for now, and then all the story is so hard, so we are having difficult to complete all the story. And for example, during April 14, and then we have been facing some obstacle during the real-time navigation, so it didn't having a big progress to close out the story points. And up we having a story was not complete during Spring 3. Next slide, please.
I'm coming to the point of the Sprint 3 test case series. So as we got from the feedback from the professor in the last class, like we reviewed the everything what we have gone the wrong improvements. So we checked everything and we done that. So we verified that for the point two, for the verify the ID backend development model code and can be successfully deployed on an appropriately configured EC2 instance. So for for this result, with the proper configurations like correct type, security group, and IAM role, and for the backend and the model code deploy successfully with all dependencies. Applications can be initialized without errors, without logs also can confirming the proper startup for all components. So and we did that and we passed that too. So can you go for the next one, please? So, and we verified the audio updates are delivered in the clear, timely, and non-disruptive manner. And we expected results. It was like uh, audio notifications are delivered with appropriate volume and clarity and with have high frequency, which is audible to good. So critical alerts are prioritized, and the user can easily understand the information without becoming like overwhelmed or confused by excessive updates. So we checked everything and we went through on that. It was good. So we passed the test as we expected. So and we verified the visually impaired users also can easily input the source destination using accessibility features. But this also we expected as the UI elements are properly labeled for the screen readers, voice like input works correctly, and all the input fields are also working good. So navigable using keywords, shortcuts, and the users can successfully enter the location without visual cues also. So we did that, we worked on that, and we passed at the test too. So everything is went well. So can you move on the slide, please? Here we go.
Here is the Spring team velocity and commercial rate. During Spring 1, we have commit 45 story and complete 45 story. Spring 2, we commit 39 story and complete 38 story points. And Spring 3, we have commit 49 story point and complete 41 story point. The average of three during the 3 spring is 41.3 story points. And during Spring 3, out of 49 commit story, 41 story point was commit, and the commit ratio is 84%. Next slide, please.
Yeah, so Sprint 3 retrospective. So what went well in the Sprint 3? We integrated our APIs on time, and the team meetings in this sprint, we kept the meetings a bit shorter, and this way we were able to have more effective meetings. And we prioritize our tickets and features clearly this in this sprint. And other one was the comprehensive documentation covering all the use cases. The next one was successfully implemented the professor's feedback, like the demo video, uh, the better version of user story descriptions and all. And then we completed code development features on schedule. Yeah, and effective code synchronization and review process before merging code. So yeah, we took care of all these points in this semester, sorry, in this sprint. And what needs to improve, better planning and time management. So some of as we show that we were not able to complete a couple of stories, and it was because we pushed development till late, and because of that, we didn't get much time to do the rest of the work. So what we need to do is we need to plan better and time management. Other thing was ensuring everyone joins the sprint meetings regularly. Yeah. And the third point is avoiding last minute merging of features. So which gives less time to test and deployment. And the fourth point is setting up initial API infrastructure earlier in the process. Yeah, this way we could get so most of these points are related to better planning and timeline. And the last point is standardizing the installation manual to make it more simplistic with clearer steps. Yeah. And the action items for these are, implementing weekly timeline check-ins to assess progress against milestones. This is for the first point. You know, for ensuring, sprint meetings regularly, we need to set like calendar invites with automatic reminders like 1 hour before the meetings. This way everyone will remember that they have a meeting to go to. The other thing is, establish a code freeze policy. It could be anything. Ideally, it should be like 48 hours before the sprint end. This way, we have enough time to test and deploy. The last thing is, about the installation manual. So what we need to do is we need to test these instructions with a team member like who wasn't involved in writing these instructions. This way, we would make sure that the instructions are clear and easy to follow, and every instruction is working, and we're not missing any crucial steps. So about the project demo, so this is a screenshot of our authentication slide. So we are using Clerk here. It gives us, sign up options using, we could use username, email address, and password, or we could use, Gmail. It gives us other options as well. We implemented these two in it. And once we log in, we can see this is our local stream, which is like a camera feed of our laptop. And this is what we get from the first API server, and it is detecting that there's a person in the frame. And so, yeah, this is connected via WebRTC, and this is getting detected by the YOLO model, and it is calculating the confidence score and everything else. This slide, represents the maps part of our project. So this is we have implemented Google Maps API. Here we can enter, the source and destination, and we can get the directions to our destinations. Yeah. And this slide is one of the APIs which we implemented. So this is the API which we would hit to get the audio files for the real-time audio feedback, which we would give to the visually impaired users once the any object is detected in the frame. We would hit this API and this with a text, like let's say a person is detected, we would send a text like a person, and which in turn will give us an MP3 file with the text. Yeah.
This is the backend API. So whatever the YOLO detects, the YOLO model goes back to this API, and this API further gives it to the text to speech. So what this API does is it takes the detection part, the text part, and forwards it to the text to speech. So this is the main, like the connection part from the front end to the back end, which is this API, the detection API. So it is a very long API. So I can it takes multiple inputs but gives only one output, that is the audio part of the text to speech. Yeah, that's it. Thanks. And this is it's a big API, so we have included 3 slides to fit the only one API. Thank you.
Here's the wiki page of our project. If you're interested to learn more about our project, please use this link to find more detail.